Usually we monitor filtration by pressure drop. If we get a certain amount of pressure drop from the inlet to the outlet side, generally somewhere 8 to 10 psi drop in pressure, we know it's time to flush the filter. And on more sophisticated systems, it'll automatically do it. It's all set up. As soon as the pressure drops 8 psi, automatic flush cycle comes on. That can be done. Other systems, they'll be set up on a timer, and they know that every 10 hours of runtime they need to flush, just for example. And so after 10 hours of run, it'll automatically flush. Or it'll flush every time the cycle operates. So every time that zone operates, it'll flush the filter for that zone before the zone comes on. So they start with, or it'll flush right at the end of the run cycle, so that it cleans all the debris out at the end of the cycle, and it's clean for the next run. But lots of times the filtration is all in one common area, and it'll just do a flush on a certain cycle, a timed cycle. And if you have a bank of filters, it'll just be flushing a different bank continuously around that loop. And there are some very, very large filter stations out there where there are literally hundreds of filters at a station when you get into these 2,000, 3,000, 4,000 acre fields. And out here on the river, along the Columbia, we will find some of these large cottonwood plantations that are that kind of size. It's not uncommon to find 1,000 or 2,000, even 3,000 acres of cottonwoods in one continuous block out there, with 1 or 2 pump stations supplying the water to them, and very large filter stations in the process, because they're pulling river water out. And we have to filter for 2 things. We have to filter for inorganic chunks that are going to come through the system. If we're pumping out of a well, for example, that would be sand. The biggest fear we have with well water is pulling sand out of the well. And those little sand particles, if they work their way into a drip emitter, they'll plug it. Now the good news about those things is they don't grow. They just roll down the pipe and eventually, hopefully, go to the end, and you just flush them out the end. But occasionally they'll end up getting diverted into an emitter, and then it's going to plug the emitter. That's the most simplistic. The tough one is the organic material. So whenever we're pumping surface water out of a canal, out of a pond, out of the river, out of a lake, out of a stream, we're going to have algae and other organic organisms in that water. So we have to be able to filter that gunk out of there before it gets into the pipe, because it's going to plug up those emitters. 2 basic kinds of filters for that. One of them is a disc filter. You just have stacks of discs on top of each other with very small gap between them, and they're generally about yay big around, and water comes up through the center and has to work its way through these discs, and they're just compressed down on each other, and they look almost like an LP record, except instead of slotted around, they have little tiny slots radially in them. And as the water tries to get through it, the debris gets caught in the little slots. And then every so many hours or days, whatever the flush time is, what happens is it allows the discs to float loose. Instead of being compressed, then the top lifts up, and the discs then can separate, and all the crud can blow out through the centers of them and flush out. And obviously at that point in time, the downstream water is being diverted sideways. It's not being flushed into the field that you're irrigating. It's being flushed sideways. So you have to get rid of that flush water, either by putting it out through some kind of like an impact sprinkler system that has big orifices on another part of the field, or just putting it into a drainage ditch and sending it downstream, or into a settling basin where it'll just evaporate. But somewhere outside of the drip system. We can't afford to have it inside the drip system at all.